In this video, we are going to do tutorial for everyone who would like to start with ESP32, and especially we are going to cover the Arduino environment and also the Espressif IDE. So this is something what is very important. I think many people, they know how to work with Arduino environment, but this other Espressif IDE, it has also some advantages, and maybe it's good to know how to do it. Correct, Amir? That's what we are going to talk about.
Yes, yeah, let's do it. Hello, everyone. It's good to be here. Thanks, Robert, for inviting me. So let's go through the basics of ESP ecosystem, and especially ESP32 microcontrollers.
So basically what we are going to start with is talk a little bit about the modules or the hardware, so
Yes,
everyone knows which one to use, because there are many different
exactly.
options. And
Yeah,
then we will pick one, and then we will show how to install the environment, and then we will run some examples.
exactly. So this is the Espressif website. It shows all of the modules and SoCs they have. And by SoC, I mean system on chip. And it also kind of shows the history. So their original processors were called ESP8266, which basically were the lowest power microcontrollers. I guess no one is using them for industrial or any serious project. The most common and the most famous processor from Espressif is ESP32S series, which is based on Tenslinka processor. It is not ARM as we used or as we are used to play with some like most of the ST microelectronics or other common microcontrollers. They have ARM processors, but ESP32S3 especially has a different processor. But it is quite powerful, and in some aspects, it is better than ARM. But there are different comparisons we can do. So
I have a
usually,
question. I have a question. So do you know what is the main difference between H, C, and S?
so the main difference is that our microcontrollers. Are you talking about these series,
Yes,
or are you?
exactly.
Okay.
Yes.
So the C series, they are based on RISC-V processors. So there are a category of processors that are based on the open source instruction set called RISC-V. The H series, and then there is a P series that is not yet mentioned here for some reason. They are mainly on, they have been optimized to do certain optimizations, certain processing, like DSP or graphical displays. So they are well designed for specific applications. But the most general purpose application microcontroller that we can find is called ESP32 Series S.
All of them, they have support for Bluetooth and Wi-Fi, or only the S series?
Some of them they don't have Wi-Fi.
Mm-hmm.
Some of them, for example, ESP32 C series, or they only have Bluetooth or BLE-V5.
Mm-hmm.
But majority of them they have a network coprocessor. For example, ESP-C C6 series is a single core processor that runs both Wi-Fi stack and Bluetooth stack on the same core. But for example, ESP32S3, it is a dual core microcontroller. So one processor is allocated for BLE and Wi-Fi, but you can choose in the software which core is used for what application. But when you have two cores, you have a better performance
Mm-hmm.
with the same characteristics.
Mm-hmm. So one is handling the network, and the other one can handle your application, for example.
Yes, exactly. So ESP32S series are not optimized for battery-based applications, although the consumption is pretty low, but they are not optimized for those applications.
Mm-hmm.
I suggest taking a look at the C series. H series also have the single core processor. Usually they have the same characteristics because it is the same company, the same cores, soft cores or hard cores are being used on the FPGAs and these processors. So, but they are designed for different applications. The H series especially is designed for low energy
Mm-hmm.
applications. And probably as you can see, I mean, the clock frequency is a bit lower.
Lower. Mhm.
So it shows that, yeah, it's designed for these type of applications. But yeah, the exact model, you have to go through the data sheet and see how it goes. The good thing about Espressif products is that they not only give you the SoC, or let's go through the S series. So they not only give you the SoCs, which is basically a chip, they give you modules which are designed for optimal performance. And also, the very important thing is that they have gone through the certifications for there are some FCC regulatory certifications and Wi-Fi stack and Bluetooth stack that usually these products, I mean, every product I know, they have to pass these regulatory requirements to be able to be released to the mass market. And the good thing about the modules is that they have already passed these certifications. And if you are designing a product and this component or this module is the only part that is doing the communication part, you don't need to do the retesting for the final product. And
I will interrupt you here. Actually, I recorded a video which is not published yet, but maybe if someone is watching half year later after this, it's already published, where we go into details when certification may be needed, when the certification is not needed. I will attach screenshot from the video somewhere here and people can watch it.
yeah,
So we don't need to go into the certification details. What I would like to point out is basically these modules make it easier because, for example, one of the hard part designing this kind of board is antenna design, antenna tuning. So on the modules is already done, so we don't have to do that. Also, do you know if Wi-Fi and Bluetooth can work together at the same time?
Yes, yes, there are RF switches because they both work on 2.4 gigahertz frequency. It's only about the coding and the way that the signaling works. So I don't go into the RF details, but these you can see these modules, they have the same antenna, and then the modulator is different based on the protocol. So it switches very fast between the 2.4 gigahertz for Wi-Fi and Bluetooth requirements, but they coexist. Basically, it's called coexistence.
Mm-hmm.
And there are some limitations to coexistence. So these generations of ESP32, especially the S series, they have improved this coexistence because there are different, I would say, situations, different it's like a state machine, this Wi-Fi and Bluetooth. So these state machines, sometimes certain states, they cannot coexist together. For example, when a Wi-Fi station device is connecting to a router, at that point, BLE advertisement might not work.
Mm-hmm.
Some tricks, and then you need to know as an application designer that you need to prioritize in those situations. This makes development of Wi-Fi applications and BLE applications a bit complicated. It is this fine-tuning at the end that makes a reliable product that works every time, and the user doesn't notice these issues related to the coexistence.
Mm-hmm. So this is
Math-
maybe, for example, one of the reasons why we would like to work with Espressif IDE and not
yeah.
in Arduino IDE, because Arduino IDE is very high level programming, correct?
Exactly. So yeah, Arduino we will go through it in the next few minutes, but Arduino gives you a precompiled version of ESP-IDF SDK with a predefined configuration. And that configuration is fixed to at the build time of the Arduino
Mm-hmm.
library, which was tried to be general purpose, but different applications require different configuration. You can still use Arduino and ESP-IDF, but you need to build it yourself, which you need to know how ESP-IDF works.
Mm-hmm. So, and for everyone who is really starting with ESP32, what we just mentioned is how we are going to program the ESP32. So everyone will see a
Yes,
little bit later what
yeah, we
is
are going
the
to talk about that.
what we
So
are
I
thinking.
suggest we continue
Um,
on the hardware side.
mm-hmm.
So I mentioned Espressif provides both SoCs here, so it is basically the chips
Mm-hmm.
themselves. So it is the
Yeah.
IC that you can put on your PCB, and but you are then responsible to design the whole circuitry, the antenna, and then doing the RF side. For beginner products and projects, I don't suggest using them unless you want to design a custom PCB with a different form factor. Uh, but the most common uh, products of Espressif are the modules themselves and, well, dev kits for testing purposes.
Mm-hmm.
But the modules, and the most common one is ESP32 S3 series. This is the most recent one. It has been released, I guess, 2 or 3 years ago. It uses X-Tensor 32-bit dual processor. And the clock frequency is pretty high. So you can run with this clock frequency and then the LCD controller included. You can do pretty good animations with the LCD controller on small LCD displays, which is quite powerful. They have a large SRAM and a large ROM, but usually what happens is that the ROM is not used, and we usually flash program the flash that is externally extended, and it is inside the SoC, but there are different variations we will cover. And this flash is connected through SPI lines. Sometimes it is dual SPI, quad SPI, or octal SPI. So when we say dual, quad, or octal, it means that the SPI data lines are either single data line, it is a classic SPI, which is MISO, MISO, these terminologies. But the dual one and quad one, you can transmit data a lot faster.
Mm-hmm.
So as the flash size increases on ESP32 modules, the data transmission speed also increases because you are trying to manipulate lots of data and then you need higher bandwidth.
Mm-hmm.
So they have these modules, they have almost all of the standard peripherals. So one thing that was always that is always a limitation on modules themselves is the number of peripherals, because not all of the pins are out, or in general ESP32 SoCs, yeah, they are fixed, that the number of peripherals is fixed. So if you want to, for example, have multiple SPI communication with different no, components on your PCB or on your product, you might reach some limitation, because the SPI peripheral embedded into the chip, there are not that many of them. So some depending on the model you have. So you need to decide on the peripherals you want to use before choosing a product. But here, for example, the most common one is ESP32W Room 1, which has two variations, as you can see here. So it is W Room 1U and W Room 1. So as you can see on the picture, this has the antenna connector. It is a UFL connector, but it doesn't have any PCB integrated connector on it. So it depends on your
PCB
application.
antenna.
Some products you want to connect the UFL connector and connect it to an external antenna. So then, yeah, it gives you this flexibility if you want that. Some older modules, they had both. I don't see them on
Oh,
3 series, but on the I guess it was on, yeah, on this, for
oh
example,
yeah, I see.
where you can see there is a UF connector.
And down. If you go down, there is also.
Yeah, and here, yeah,
Yeah, yeah,
this
yeah.
is that has both of them. But depending on where you mount this, you can you can decide which one to use. It gives you the flexibility. But the problem is that the latest modules, they don't have it. Probably there's a good reason for it.
Mm-hmm.
Uh, so most of them, they have different form factors. So depending on the application you have and the size limit you have on your PCB, you can decide on the exact module to choose. Well, the most common one on ESP32 S3 series is W Room. This is the most powerful one, actually.
Mm-hmm.
And then the dev kit, the most common dev kit that is found for ESP32 product is called dev kit
Mm-hmm.
C1 or dev kit C, which, well, I guess there are links to the project themselves. It discusses it. We will go into the details
Is it this one what you have on your table?
we are going to discuss that, yes.
But I mean, is this the model which you have on the board? What you have on your
Yes,
table?
this one I have. It is ESP32 S3W Room 1. This is
Mm-hmm.
the exact model that we
Mm-hmm.
have.
Because
So
I think I use also the other one, the smaller one. So if someone needs the smaller model, they have also a smaller one.
yeah, they can use a smaller one, but then they need to make sure they connect the antenna because without the antenna, you can't use the Wi-Fi or BLE
Then,
capability.
but then is also the mini, I think.
Well, there is the mini one, so you can see they have put the size. Let me
Yeah,
just put
it's a little
here.
bit. Yeah, yeah, yeah.
Yes. Exactly. So you can see this one, the dimensions, for example, the width, the height is 15 millimeters, but this one is 18 millimeters. But it is about the number of pins as well. So here,
Yes, I know.
if you look at this exact module, I guess it has the pads underneath the PCB as well. So here on W room 1, all of the pins are on the side.
Mm-hmm.
So you don't have any other pins on the bottom of the PCB.
Mm-hmm.
On this one, to save a space, probably they have put some stuff on the bottom. So when you put it on your PCB, you need to make sure you route the correct signals underneath. Then you can see as you can see, it is smaller, but the number of pins exposed is even higher.
Mm-hmm.
So yeah,
But it's
depending on,
harder to solder
well, it is, yes. Yeah, you need to,
manually. I mean, manually.
yeah, you need a heat gun and there are different methods, but yeah. You
Okay.
can find dev kits for that, I mean, if you want to just give it a try. But yeah, it is a good device if you have shortage of space.
Mm-hmm. Okay. So I think we can now move to the next point. What is the
Yes.
next point? So we
Yeah, I wanted
we we
to,
know what we would like to use. We would like to use the
yes.
room.
So we are going to use this one. This is the one that we already have, and the examples we run will be on it. As you can see, the description is nearly the same for all of them. So all of them, they have Bluetooth and Wi-Fi. It is the number about the physical dimensions and the number of pins.
Mm-hmm.
So let's go through the DevKit C1, which has this module. We this is the dev kit that I have on my on my desk, and the only difference is that this picture is a bit older. It is with USB micro
Mm-hmm.
connectors. Here's USB-C, and the ones you find on Amazon or anywhere you want to buy, it comes with USB-C connectors. So make sure you get USB-C cables,
Mm-hmm.
USB micro. So uh, it it the Espressif documentation is quite comprehensive. It was not the case maybe 5 or 6, 7 years ago, and that was always a criticism against Espressif compared to, for example, Nordic Semiconductor or other microcontrollers at the time that were present. That the documentation was not good. It has improved a lot in the last years, and basically it has covered all of the use cases you might have, and all of the issues are covered. It gives you a basic overview of the board itself. The board we are going to work, it has these pin headers. When you get them, they're soldered with the pin headers, or they're just given to you and you need to solder them yourself. So it is depending on the design you have. Uh, there are a few LEDs, but the one that you can control on this board is an RGB addressable LED. So it has a single GPIO connection, but you need to uh, address using a specific protocol. It's a simple one to which LED you want to turn on. We will see it in the code itself. And then this is the power LED. Then there is a USB to serial connector here, so the USB to UART. And the good thing about ESP32 is that it works based on UART. To program the device, it uses UART. And if you want to use a debugger, you can use JTAG debugger. It provides a JTAG interface, but the UART interface also gives you the debugging environment using OpenOCD. So you can basically track line by line using the GDB debugger.
I didn't
Uh,
know this.
yes, yeah, it is possible, and they have put a nice documentation around it. It is a bit complicated, but if you want to really debug the code on the microcontroller line by line and set a breakpoint, that's a pretty useful feature.
Can you use the USB which is directly connected to the chip? Can you use it for debugging?
Exactly, yes. So this is the second application of this USB port. So this USB port exactly is connected to the USB pins of
The chip.
the Espressif, And then, yeah, it gives you the JTAG profile on the USB. So basically, it
Mm-hmm.
is an embedded JTAG debugger on the board, which directly you can connect and then install the driver. They have put documentation on the website on you can connect and install the driver. On Linux, it is already uh, shipped with
But maybe
immediately.
I would like to point out here. So maybe
Yes,
this can be the advantage of using the Espressif IDE. So the software which
yes,
we will use to program this board. There are two options. One option
yes,
is the Arduino software, Arduino environment, or directly the software provided by Espressif. But if you use the Arduino environment, it is simple. There are many examples. It's super simple to start with. Everyone knows how to work with Arduino environment, but there are limitations. And one of these limitations is the JTAG, for example.
yes. Yeah.
Mm-hmm.
In Arduino, you can't use a JTAG debugger. You can program it if you do some settings, but you cannot debug code with the
Mm-hmm.
debugger using Arduino.
Mm-hmm.
So to continue, this is the introduction to the module itself. It has a full description of it and how to set up the board, the buttons. So there are two important buttons on the board as well. So there is boot and reset.
Mm-hmm.
So reset is a typical reset. The reset mechanism on ESP32 is a bit different than the reset we know because this reset is connected to the EN pin of the microcontroller, but it doesn't reset the microcontroller. It has a circuitry in between that's eventually it resets the microcontroller, but there is a delay. Sometimes it might be tricky. I don't go into the details of that,
Mm-hmm.
but you can't just see it as a reset. And then there is a boot, which basically tells the Espressif to boot either it's connected to the boot mode, but it tells it boot the flash or it boots to a programmable mode, which you can
Mm-hmm.
download the program.
Mm-hmm.
But you don't often use the boot mode because the USB to UART converter already brings the device into the boot mode.
Mm-hmm.
So it is all automated, at
Mm-hmm.
least on the dev kit itself. But when you put the module on your product, you need to make sure that you have this pin, the boot pin,
So you can reflash
somehow.
if you need.
Yes, yeah, you need to bring it out so you can, at least if you put it on a jig or any sort of debugger, you can flash it.
So basically, without the boot button, it can always boot up with your application, but then you would not be able to go
Yeah,
and
you will not be
refresh.
able to do it. Yeah, you need to program it until you uh, change the boot. So you
Mm-hmm.
need to control the signal on it. So the I don't go into the details of it. There are some schematics here. The pins, so you can see the pins have different functionality, but you can configure them during the boot. There are some strapping pins as well on the board. They are defined in the data sheet. So most of the pins are all of the pins are GPIO, so you can use them for GPIO applications. But you can also use them for a specific application like ADC, or if you want to connect a touch input. Some specific ports can be used for new UART ports. For example, U0 and U1 are for new UART ports that you want to use. Some of them they can be used for external clock source if you want to use the RTC functionality. So when you this is quite important when you want to design a product based on these modules, you need to make sure you set the crystal port correctly so you can use the RTC functionality. And some strapping pins are also needed if you want to use the highest speed SPI port or, well, the naming of SPI uh, peripherals on ESP32 is a bit misleading, but it basically means there is a main SPI and a secondary SPI, so you can have two SPI interfaces. But when you use the second SPI interface, you lose some of the other functionalities on the pins. So it
Mm-hmm.
is to you to decide which one to use. And yeah, the pins are defined here. This
This
is
is nice.
a
I use the picture a lot actually, especially for example, if I'm looking for pins which are supporting, I don't know, I2C or
yes.
you are in this picture very nicely. You can see which pins you can use or connect.
Exactly, yes. Yeah, this feature is quite useful. Sometimes you can, usually when you want designing a product, this is what I usually do myself. I create an Excel sheet, I put all of the pins, and then during the design review, we decide on the functionality of each pin, and we make sure we don't lose pins or don't go out of pins.
Okay, we can go next.
Yes, yeah. This is a schematic of it. Yes, this is the schematic of the dev kit, and you can see that the schematic is just a single page. I mean, it doesn't have anything very advanced, but it gives you a clue of how, if you want to embed a UART, USB to UART programmer, you can see the DTR signal and RTS signal. DTR for USB to UART is data ready, data terminal ready, if I am not mistaken, and then uh, read signal ready. So there are these ready signals. So as you can see, this circuitry, basically this GPIO 0 is the boot pin, and then the power arrows, basically this is the reset. So you can see the programmer uses these two pins from the USB to UART chip to bring the SoC into program mode without pressing the boot button directly. And so this is quite important. Sometimes, I mean, usually the products they want to put a programmer on the PCB as well, so you can put these circuits on your design as well. The rest is nothing important. So this is the RGB LED that we
This is
want
what
to.
we are going to use today.
Yes, it is. So this is yet a bit different from the normal LEDs on this dev kit because you have three RGB LEDs on it, so it is an addressable protocol. The library already includes that, so we will see how it goes. It's pretty simple. So I guess that's it for the hardware side of it. We can start switching on programming the ESP
Okay.
microcontrollers.
Okay, let's do this. I'm curious. So first we will need to. Oh, if we start with Arduino, do we need to install something?
Yes, you need to first install Arduino itself, but the rest of it is pretty straightforward. So I recommend you follow the installation of Arduino. So we can just go to Arduino website, and because I'm using Ubuntu here, you can download it. Let me see if I can have access to the download link from here on Arduino. I guess the link
All software. There is
there
all
is Arduino
software.
ID. Yes, yeah. So this
Oh.
is the download section. So depending on Windows, Linux, or Mac you have, I've already tried it on Windows, and it is somehow easier on Windows than Linux because on Linux there is a catch, especially on recent Ubuntu 24. There is an issue with the app images. So I recommend installing the zip file for the Linux version. But at the end, it is all right, I mean, depending on which operating system you have. So you can just download it. I've already downloaded it, and it
Install
is
it.
straightforward. So you can see I've already.
Oh, you have the easy EDA offline.
Yes, I use EDA when for designing some PCBs. This
But
is, yeah.
I never tried the offline version, so it does exist and it works.
Yes, it works. Yeah, that's all right. Yeah. EasyEDate is quite useful. I guess I've already installed Arduino, so I've already extracted it. But EasyEDate is it is simple, but I like its simplicity because I can start quickly and design something simple as well. I guess for simulation, it lacks the simulation support, which some you don't need for basic projects. If you want to only design a hardware, I recommend EasyEDA. So once you extract Arduino, uh, it the IDE, the executable is here, Arduino IDE. For some reason on my machine, Ubuntu 24, when I want to launch Arduino IDE, it gives this sandbox error, which is basically it is an Electron app, it is a web app. And there are some security configurations in Ubuntu 24 that doesn't let it to run by default, but you need to pass this argument, no sandbox, to it. But
On
if you're on
Windows, it just runs. So people who are using Windows, they don't need to
response, you don't need
worry.
to worry about that. Well, I spent around an hour to find out why Arduino doesn't run
If
on
you
my
ask,
machine.
if you ask Chat GPT, it doesn't say.
Yeah, it might be able to tell. Yes, exactly.
Actually, I use it a lot. For this
Yeah,
kind of work, these kind of questions, ChatGPT is very good because you can
exactly.
immediately test it if it's right or not very often.
Exactly. Yeah, that's that. I guess yeah, it can search online as well. I really recommend taking a look at these AI the AI assistants, and I'm using it a lot on my projects, especially for embedded projects. They're quite useful. For ESP32, they are more useful because the whole documentation, the API is available publicly online. And these AI agents, they can easily find out the information and the most up-to-date API available. So that's a good thing. When something is open source and available, it gives this advantage to them that can be used by these AI agents, AI
Hmm.
assistants.
But what I
So
found out, sometimes they mix different versions or different stuff, and then basically the software what they create, it's uh,
exactly.
you need to just always like copy and paste the errors to fix it.
Yeah, you need to supervise it. You can't just rely on it. But if you want, for example, to implement an algorithm that is somehow independent of the APIs exposed by the SDK of the microcontroller, they are quite useful.
Hmm.
And they can understand the context as well. So if you just give them the list of the APIs you have, in this giving a good context to these tools, it maintains a good response from them as well.
Hmm. Okay, we can continue. So this is how the Arduino environment
Yes.
looks, and
Yes,
basically here is where we can write software for ESP32,
exactly.
and we can use it also to flash the board.
Yes. So the famous Arduino sketch is just a setup and a loop. So it is basically setup runs one time and loop runs like a loop every time. So
Forever.
this is the main functionality of Arduino, and it is its simplicity that has caught a lot of attention by Arduino. So to install the ESP32 SDK on Arduino, we have to go to Preferences, and then there is this section Additional Boards Manager URL. So this is what I have already copied from the ESP Espressif documentation for Arduino. So yeah, I can even show you how I got it here. If so, here it talks about well what Arduino ESP32
Hmm.
provides. It tells you which SoCs it supports, but it mainly supports all of the common ones and that Arduino uses. The installation is pretty good here for different operating systems, but the main thing after you have installed Arduino, you have to choose. It's like Debian on like a Linux package manager. Arduino has its own package management system. So by just pointing to the right server, uh, which is basically the release link as in Arduino ecosystem, it can find new packages and then Arduino can install it for you. So here they have put two links. One is for the stable release link, which is basically the stable releases of Arduino SDK for ESP32. And this one is the dev version. So it is following the head of main on the ESP32 GitHub repository. I recommend using the stable one. And if you only want a specific feature that has been added recently and you want to test it, then use the development
Hmm.
release. So you can just copy it and go to Arduino, and then you can just paste it here. I
Hmm.
have already done it before, so it's there. Once you press OK, you need to go to the board manager. So you go to
Hmm.
board and then board manager, and you can search here ESP32. Uh, this one I've already installed it, but once you search for it, this is the ESP32 by Espressif Systems.
Hmm.
Is the SDK that ESP32 officially releases.
So,
There is
so this one
another,
is basically from the link what we just inserted there.
yes,
Hmm.
exactly. You have to download the latest release.
Hmm.
There is there is just one thing you shouldn't confuse this with the Arduino ESP32 boards. So this SDK is provided by Arduino, but it only supports a specific Arduino dev kits that come with
Yeah,
ESP32.
I think these are the dev kits with the kind of wireless possibilities. They solder down ESP32 on Arduino board.
Yes,
Hmm.
exactly. So here you can see Arduino Nano ESP. This is only one board, I guess Arduino produces.
Hmm.
Officially, they support with ESP32. But for the rest of the dev kits, this one is
Hmm.
the common one.
Mm-hmm.
So once you have installed it, then you have access to all of the examples. You
Mm-hmm.
can go to file examples, and then it shows ESP32 dev module. So before, it doesn't show it by default, but you need to select a board and then connect it to your PC before it can detect it. So let me see why it didn't detect my device for some reason. So here you have to go to the module itself, and then you have to specify which module you have. I have ESP32 dev module, which is
Mm-hmm.
basically the dev kit we got. So once you select this one, it shows the examples for that board.
Mm-hmm.
And yeah, all of the examples, there are different functionalities. So we want to use the Arduino. Let me see, there is a blinker example that we need to find. So ESP32 and let me try GPIO and then
Mm-hmm.
RGB. This is the
Mm-hmm.
example that you want to use. So it opens a new Arduino with that. I close the previous page, and this is the one we got. So let
Mm-hmm.
me just make sure it is on the right size. Basically, we don't need to change the code here, and it is pretty straightforward. So there is no special setup. And because this is a dev kit, it is supported both by Arduino. This RGB built-in uh, it is a definition, it is a compiler definition that has been already added. So it basically points to the GPIO pin that is connected to the RGB, but it is already defined. If I control click on it, it goes to RGB built-in, and then uh, if I go to built-in here, it shows which pin it has been connected to.
Mm-hmm.
So it is already
48.
defined in the pins Arduino. When you select the specific board, that definition is already
I
there.
didn't know. So you can do control click and then you will find the definition.
Exactly, this is what I
Mm-hmm.
did. So when you do control click, it worked for, yeah, here it worked.
Mm-hmm.
And can go through this. This is a nice feature of IDE, of Arduino IDE. But VS Code has far better support for this sort of source code handling.
But this is good to know because sometimes this software may be for different dev kit and LED or something may be connected to different pin. So it's good
Yes,
to know how to double check if the software is written for the board what people are using.
exactly. Yeah, that's correct.
And if
So
it's
now,
not, then everyone can change it.
yeah. No one. It is something predefined, but you can, if you have a custom board, you need to define this pin map yourself.
Mm-hmm.
At the end, the pin number is an integer. So when you are calling digital write, you need to pass the correct pin number. If you don't want to use that is coming by Arduino, or if it is wrong, then define your own
Yeah,
pin map.
it's commented out in the first line. Yeah.
Exactly. Yeah. This is the brightness, and then exactly. So let's compile it. The first time you compile it, because it compiles lots of files, it might take a bit. Uh, the good thing with Arduino, the ESP32 Arduino support is that it comes with a pre-compiled library. So we will see when I switch to ESP-IDF that the first build takes a bit longer because it recompiles everything. But for Arduino, it is already pre-compiled. So it only compiles your application and link it to the static library that comes from ESP32.
But there's also this advantage what we were talking about before, like you can't really sometimes do very low level programming because it's already precompiled.
Exactly. If you go to the documentation of Arduino, it says that I guess there is advanced utilities library builder here. It tells you how to build the library yourself with
Mm-hmm.
a specific configuration that you want. So here you have to use idf.py. There it is this config controller. that you can specify which configuration it should choose. So there is I guess it is a long tutorial as well on doing that. There are Docker images as well that you can use if you don't have the host environment. And in the FAQ, even it has mentioned, for example, yeah, how to change the SDK
Mm-hmm.
config in Arduino. And it basically tells you that you need to use the library builder to
Mm-hmm.
build your own because it is already pre-built
Mm-hmm.
when it is shipped to you.
But
So
I would
I
like to
we,
point out if someone is using Arduino environment, they don't need to really worry about this because they probably would
yes,
like to try it only with this
yeah.
very simple way.
Yeah, for almost, I mean, 90% of applications, the default configuration is enough, unless you want to use I don't know, some specific feature or change something in the Wi-Fi stack. So let's see if the programmer works as well. I need to just choose the right port. For some reason, the port is not connected, so I try to connect it again, see
Disconnect and
if it,
connect, yeah.
yeah, hopefully it detects it. Yes, it has
Yeah.
detected it.
You can move
So,
the board a little bit further because it's
yeah, oh,
getting
yeah.
blurry.
Is it better now?
Mm-hmm. It's perfect.
Perfect.
So now
So
we are
what?
going to, no, okay,
Yeah,
continue.
yes. Once you connect it, it gives you the TT by ACM0, which is the serial port.
Mm-hmm.
And if you already have programmed it with Arduino, when you call get board info, it gives you some info. If you have not programmed it with Arduino, as here it says unknown board, because
Mm-hmm.
Arduino has a specific serial command that it can detect the board, and it has a specific bootloader here as well. But you don't need to use the bootloader here. There is a feature of Arduino that you can have a bootloader and then use the programmer to do it. You only need to choose the ESP tool to program the ESP32. So I will go through the config as well, but these are the steps that you need to follow in Arduino. So before
I never knew there are these features. I always just press program and
Yes, yeah, but it is good to know about some of these features. But let's go through them. So when you
okay.
specifically choose ESP32 modules,
Mm-hmm.
it gives you all of these options.
Mm.
You can stick to the default values, but it is good to know what they mean. So USB CDC on boot basically means that the USB profile, if you use the other port, so I can point out to the here. So if you use this USB port, it directly is connected to the USB pins of ESP32 module. You can enable it at boot time. For our application, we don't need it, so we keep it as disabled. You can also change the CPU frequency for a specific application you have.
Mm-hmm.
The higher frequency, it consumes more power. So I guess you want to go low frequency for low power applications.
But then you can't have Wi-Fi because it's not powerful
Yes.
enough.
So yeah, at least you need 80 megahertz CPU processor
Mm-hmm.
to be able to use Wi-Fi and BLE functionality. The debug level, you can specify how many logs you want to see. Basically, the ESP-IDF internal calls, they don't always log what they are doing, but depending on the debug level, you can specify what it should. The verbose is the most verbose debug level, which basically prints every step it does. But there is a catch. When you have more debug, your application runs a bit slower because for every serial command, it has to go to the serial peripheral and send something. So it is going to make the application a bit slower,
So there is
especially,
some kind of debugging option even in this Arduino environment,
yes,
but it's
yes,
not the like debugging in the Espressif environment, like going through line
yes,
or
yeah, it doesn't go through line by line, but it prints
some
the debug
outputs.
lines that you
Mm-hmm.
already have put in your
Mm-hmm.
code or coming from the SDK.
Mm-hmm.
But it is a pretty good feature. If you are going to use interrupts, I recommend not to use any sort of print inside the interrupt because some interrupts you want to take them in microseconds,
Mm-hmm.
and when you use a debugger, it makes it slower. So there is a USB DFU. So DFU is a USB profile that lets you treat the device as a programmable device. So you can program the the ESP32 microcontroller flash through the second USB port and without the USB to UART debugger. This is quite advanced. We don't go into it, but it's a feature that should be enabled if you want to use it. You can also configure if the flash should be erased. Sometimes you want to store, especially if you are on a web server, you want to store some data, uh, like the HTML files, the JS files that will be shown when you are on a web server. But sometimes you want to erase the whole flash because you have multiple partitions. One partition includes those data, and you want to reprogram that data. So sometimes it is useful to erase the whole flash. Here it talks about the event queue. So it is a programming concept in sort of Wi-Fi applications, Wi-Fi and BLE. So there is a Wi-Fi stack or BLE stack that runs on one processor. It's like an state machine. You can see it like that. So whenever the state of the stack changes, for example, a new Bluetooth device is connected or Wi-Fi is connected to a hotspot, it signals an event, and then the event handler should run separately on a different core. So it is better to keep them different depending on your application. So if you have both Wi-Fi and BLE, it's better to run them on one core and the rest of your application in the other core. So it doesn't create a bottleneck for your application. The flash mode is basically the flash frequency. By the way, these configurations apply directly when you use ESP-IDF. So, but it gives the different interface to configure. So it is quite useful to go through them now. So we don't need to go through them again. So QIO is basically this. It is the flash mode, basically the flash that is connected to these ESP32 microcontrollers, which is basically inside the chip on the SoC. Well, there are some certain versions of the SoC that have embedded flash, but the module itself has a separate flash chip that is connected via SPI to the SoC. But depending on the module you have, you can decide which connection it has. The dev kit, the W room one that we have, it has the QIO interface, which it mainly means quad interface, which has 4 data pins on the SPI for flash connectivity. And the higher the number of pins is, the faster it can fetch the data from the flash. And because the ESP32 runs the flash, runs the program from the flash address, so it doesn't load the data to the RAM, and it doesn't run it from the RAM. It runs it directly from the flash memory.
I didn't
So
know
it is
this.
quite important to yeah, the flash frequency read and write should be quite high, especially the read time, because the CPU shouldn't be stuck before it is loading the data. And you can go even the fastest, but the flash memory that is shipped with ESP32 modules, it is rated to work at 120 megahertz. But if you design your own custom module, you need to make sure the frequency you choose here matches the flash memory you have chosen on your board. So, but I'm choosing 80 megahertz here, the default value. The flash size, you can decide the flash memory size you have. When this board has 8 megabytes of flash memory, if you search for dev kit ESP32 Rover, W Rover
I think
dev
they have
kit,
different models, correct?
there are
Yeah.
different flash memories. This one I got it has 8 megabytes of flash memory. But you can find some of them that have 16 megabytes. But majority of the dev kits, they have at least 8 megabytes. So if you choose 4 megabytes, it is all right. It is still runs. It only uses the 4 megabytes space of the flash memory. I keep it as it is. So there is a JTAG pin. You can specify how it works. You can even enable the USB JTAG port, and then you can use OpenOCD and GDB to debug the application, but probably not inside Arduino. So you can use VS Code or something else. Here it says Arduino core at which core it should run. So we decide core 0 or core 1. This is the same as we discussed before. And then the partition scheme. For default applications, these partition schemes, the default one 4 megabyte is enough, but you need to make sure you choose the right one that matches the flash size you have
I
already
had
chosen.
no idea there are all these settings.
Oh, yeah, it has. You can basically have, for example, this 16 megabyte one. It has 2 megabyte of flash memory for application
Hmm.
partition, and then 12 megabyte for the FAT file system.
So
So it
basically,
is
then
good for web.
this is also connected to the if you would like to erase whole flash or only the application part, probably, correct?
Yes. So depend the when you have application partition, you can only specifically erase a partition
That's
instead
what
of
I
the
mean.
whole the flash memory.
Hmm.
Yes. Yeah. And then you have to choose. Choose any of these layouts and then decide on should you
Hmm. Hmm.
erase the flash or not.
Hmm.
Uh, and then there is a PS RAM. So this is a quite useful feature of ESP32. So the same thing as we discussed about the flash memory that extends the program memory. You have now it is like a SPI RAM. It is connected to the SPI pin of the microcontroller. It extends the RAM, the amount of RAM you have, the random access memory that you have. So it gives you this module and this feature is quite useful if you want to run AI or machine learning on
Hmm.
the edge that requires large amount of RAM that to hold, for example, a neural network. So this is quite useful because the embedded RAM inside the microcontroller, I guess it was 500 kilobytes. It is quite high, but you probably want a
Not for data. If you need to
yeah, for
process
data.
too much data, then yeah.
Exactly, yes. And for that, you probably want to go with, so you can see it only provides QSPI, so either four data lines or octal, which is eight data lines to make the operations faster. And it if but you need to design the software in a way that
It can use
it
this
is
memory.
efficiently.
Hmm.
Well, if you this is kind of advanced topic, but ESP-IDF lets you decide on how to use the different RAM sections of the memory address you have for different applications, like managing the heap and stack on your software. But these are quite as advanced. We don't need to go through them. Here you can decide the upload mode here, so you can use UART or USB OTG. So because we didn't enable USB CDC on boot, then there is no USB, and the connector is also connected to
Yeah, we are
USB
using the
UART
native
pro
USB.
exactly. And then we use the highest speed nearly for programming the flash memory. You need to make sure that your new USB cable is a bit good. It can handle this data rate. And then you can decide on the USB mode. We keep it as default. You can also enable ZigBee as well if you want to use it.
I didn't
Uh,
know. So it also supports ZigBee.
Yeah, well, Zigbee is like Zigbee and Bluetooth they share the same physical layer. It is about the software stack that is different. So when the physical layer is the same and the medium access layer is the same, it is IEEE 802.15.4, I guess, if I'm not mistaken. So that MAC address layer is the same for both BLE and Zigbee, and it is the opera stack. So it is a software thing basically. You can decide to choose Zigbee or BLE.
So for
But
everyone who doesn't know what ZigBee is, many IoT devices or small sensors or something like this are using ZigBee to communicate with some kind of central, correct?
exactly, yes. Yeah, Zigbee is for smart home devices that
Yeah,
have low power.
I say wrong. IoT. This is not IoT is connected to internet. No,
Yes,
but ZigBee is just like wireless connection
yeah, it is.
inside of
Yeah,
house, for example.
yes, you need a router. Maybe you can see it as specified. You need to, and the good thing is that ESP32 can act as a router as well. So
Mm-hmm.
it can receive Zigbee or BLE data and then because through Wi-Fi it is connected to a router or access point, it can act as a router as well. There are different advanced applications of that,
Mm-hmm.
but we don't need to go
Yeah, we
through
don't
them.
need to go into details.
Yes. So these are the basic configuration, but these configurations are the minimal configurations that Arduino provides. If you choose to use ESP-IDF, basically you can control every configurable parameter. But this configuration is a bit limited, but it is for the purpose of Arduino, and it wants to be easily accessible by the users. So now we have compiled it, and just make sure I've compiled it again, and then we can run the application. And the application itself is pretty straightforward. So it first turns on all of the LEDs on the board and then waits for 1 second. It is 1000 milliseconds and then turns it off. When all of the RGB lights are on, you expect a white light because all of them are on. And then later it rotates between different colors. So we
When
get
when you say all, I would like to point out this because first time when you said all LEDs, I was thinking
yes,
there is only one LED, but
yes,
basically there are three LEDs in this one LED, RGB LEDs. So that's what you mean, correct?
exactly, yeah. So basically there are three LEDs in a single component.
Yeah.
So let's upload it, and hopefully it has already detected the device. So it probably blinks. Yeah, you can see the board is programming. It shows the programming percentage. And once it is done,
Yeah.
you can see the LED is,
White, red,
yeah, it's
green,
going through
blue.
all of the colors. Yes, it's pretty,
Works.
yeah, good, yeah. And that's the first example we want to run from Arduino. Do you have any question?
No, no, no.
Okay, should we go? Okay, should we proceed? Okay,
Yeah.
let's run another example. This one is the HTTP server. So we are using the Wi-Fi functionality of that. It connects to a Wi-Fi access point. I have already set up an access point here, and then it connects to that. We get the IP address, and then if we browse the IP address, we see basics of HTTP server. Then we want to change it a little bit to be able to control this LED via Wi-Fi.
hmm So this is the
So
second example. We are going
this is the
to
second.
enable
Yes,
Wi-Fi
exactly,
and we are going to run web page on ESP32.
exactly. So let me find that example. If
Yeah, simple
so
Wi-Fi server maybe.
I guess it was simple Wi-Fi server.
I
Yes,
don't know
there
which
was
one you use.
HTTP client as well, HTTP update service. So that was the one, yeah. So
Oh,
HTTP, there is a web server example. I guess that's because they are well, they share the same functionality, but the example is designed for different applications. So I guess this hello server is the
okay.
one which we can use. So let it open. So I close the LED, the blink example we just ran. Let me make sure it is the right size.
Okay,
Good.
I'm curious.
So here you can see that it is just one file, and we go through the details of it. But the whole idea is that it runs a web server and it connects to an access point. This is a simple application, so the module itself, it doesn't broadcast any Wi-Fi SSID. By Wi-Fi SSID is like that when you want to connect to a Wi-Fi access point, you search through it with your phone and then you choose it. This example expects that you already have a router, you already have a web, an internet connection, and then you have a Wi-Fi server or a Wi-Fi access point, we could say. And then you need to specify its SSID and password. So you can see it is left empty, and then we need to provide it. I have already created a access point here, so I called it Amir test, and then I set a simple password for it. So it is Wi-Fi password, just like that. So you need
Mm-hmm.
to keep it inside the example. It gets hard coded for final product that you ship with ESP32. You want it to be programmable by the user itself. Or there are different methods of provision. It's called Wi-Fi provisioning. That usually happens on these devices. Because this module supports BLE, the easiest way is that to use the Bluetooth connectivity. So a mobile phone, for example, it can configure the device so it connects to a Wi-Fi instead of the user typing the SSID and password. But there are different methods, and basically it affects the usability of the device. So here we changed it. I'm going to save a copy of it because once you change an example, you have to save it somewhere before you can compile it. So I've just saved it. Let's wait for it to load. Yes. So the example, it is, as you know, Arduino is C++, so it is majority of its API is object oriented. So what has happened is that it created a server object and it has initialized it with the port 80. This is the argument it gets. So by port 80, it's a web server
That's
that
standard.
listens to point 80, yes. So it has put an LED here as well. But we are going to change the LED because this example expected that you don't have
The
a
addressable LED.
LED, not an addressable LED. So we are going to change that. But I go through this and then I will apply the change. So I recommend every time you want to read an Arduino example, instead of looking at the functions from top to top, you first stop at the setup function to see what happens when the board boots, and later go into the loop, and then you can follow the function calls from there. So here what happens is that it sets a pin mode to output. It set up the serial port. It is a typical thing in all of the Arduino examples. Then the Wi-Fi singleton object, it sets it that I want you to be a station mode Wi-Fi. When we say a station mode, it means that the device is connecting to an station. It is connecting to a Wi-Fi access point. It gives the SSID and password. It starts printing something. So there is a while loop here. It waits for the state machine of the Wi-Fi stack to be WL connected, which means wireless connected. And then it prints the dots here on the serial port. Once it is connected, it prints the IP address. And then there is this MDNS protocol. We don't go about into the details of MDNS, but basically it is a protocol that you can discover devices by their name instead of their IP address, but it only works in local network. So instead of typing the IP address, you can type ESP32 on your browser, and it opens up. It depends on your client support it. Then we have the server already defined at port 80. We specify that when the HTTP protocol, it has a root directory that then you can define handlers for different paths on the HTTP root. So here for the default one, we say handle root function. So whenever the user just types IP address as presses enter on the browser, it calls handle root. And then inline is just a test. It wants to tell you that you can define an inline function. It is using the lambda function of C++. So instead of defining a function and then calling it, you can just define and call it at the same time. And then you can also specify a HTTP 404 error as well. If there is a path that the user has that we have not provided yet, we can handle not found page. And then we start the server, we print server started, and then the loop is basically, because this is a web application, it needs to iteratively check if there is a request for the HTTP server to respond. This is the simplest way to handle HTTP servers. It waits for 2 milliseconds, and then it calls the loop again. So the client it is always iteratively listening. So let's change the LED before we program it. So I want to open the LED example that we have just, to save time, I copy paste code from it. So I just copy here digital write, RGB built-in LED high, and RGB built-in low. So first I will change here and here. then so because this pin mode, well, we can keep it like that. But the built-in RGB doesn't need to be set. As you can see here,
Mm-hmm.
it
Mm-hmm.
set it in the setup function. Also, I remove this line. I set the RGB to low here.
So low, it means it will be switched off by default.
Yeah, it will switch off. Yes. So at the boot, we want to make sure the LED is off, and that's it.
Mm-hmm.
So we don't even need this LED. Let me just check. It has been not used. Yeah, okay, it has not been used, so I can remove it. We save it, and then we compile.
Okay, yes. So this is how simple it is now to
Yes,
actually create Wi-Fi connected devices.
exactly. Yeah. This is pretty simple. Before you want to start a project, I recommend going through these simple applications or simple examples to just understand how the features of this microcontroller works, and then try to design a software architecture which involves multi-threading because I mean, Arduino is a single loop. When the default mode of it is a single loop, but you cannot do everything in a single loop, and you need to take advantage of the processing power and these co-processing applications. Later on, you will have to use FreeRTOS, the operating system that comes with ESP-IDF. Yeah, it basically gives you the productivity. So now you can see it has programmed it, but I want to print the IP address. We have to open the serial monitor here and then specify the correct baud rate. So the default baud rate that Arduino chooses is 9600. So I just clean it, and I guess I need to reset the board itself because it has already passed the stage that it has printed stuff. So I reset it.
Mm,
Maybe I
maybe double
set,
check the speed in the setup.
yeah, maybe I need to increase it.
No, you can double check the speed there, no, in the code.
Oh,
It will be
yes.
set there.
Oh, yeah, it is. Yeah, it is this one. So let me just run it again.
Yeah.
Yes. So you can see it is printing the dots, and it has quickly connected to the access point I have given it to. It has printed the IP address, and then it says HTTP server started. So we just need to copy the IP address
Mm-hmm.
here and put it in a browser. I'm connected to the same Wi-Fi network, so that's the reason I can open this.
Looks like someone is building something here.
Yes, yeah, this is quite important. So just make sure the IP address is correct, 98. Okay, you can see this is the response from the root handler. Hello from ESP32, and you can see it is coming from uh, the root handler that prints this message. Hello from ESP32. And uh, let me refresh again. So you can see on the video that it has quickly blinked the LED, but it is because of the delay for 2 seconds that we got here. I guess it's not that visible on the video itself. So we can also increase the delay, add a delay here if you want to see it. But we will see the LED later in the example we run in ESP-IDF itself. Maybe I can quickly put a delay here. 1 second.
Mm-hmm.
And this is, yeah, I forgot, this is 5 milliseconds, so it is quite fast. We don't see anything. So but I put a delay here of one.
Double the column, semicolon is missing. No?
Oh yeah, I missed the semicolon, yes. So the compiler should tell me anyhow.
Yeah, and now we should see 1 second on.
Yeah, we should see the LED blinks with a longer duration. Hopefully it all goes well. Yes, it has programmed it. So if we go to the serial port, so it has connected again. It's mentioned this HTTP service is started. We go here, you can see the LED blinked and then the response came. Again, the LED blinked and the response came. So yeah, it is quite enough time. And you can see the loading time is also a bit high for this. So
Mm-hmm.
because manually added delay, usually in production code, you don't want these delays. Okay, so this was briefly how you program ESP32 dev kits with Arduino
Mm.
IDE, which as you saw, it is pretty straightforward. But let's switch to ESP-IDF and see how we can use that. So just to introduce to the audience, ESP-IDF is the main SDK that is provided by Espressif. Uh, Even Arduino is built on top of ESP-IDF, and it is like a specific configuration of ESP-IDF that is built into Arduino, and it is provided to you. But if you want to have full control and use the flexibility of the SDK itself, then ESP-IDF is the place to go. So I close Arduino and I let me open ESP-IDF documentation. So ESP-IDF is Espressif integrated development framework, if I'm not mistaken. And the latest version is version 5.5, and you can probably switch to the older versions if you want. There is a specific versioning scheme that IDF follows. When you want to start a project, it's better to look at the repository. I guess there is the repository link here. Let me quickly see. Yes, ESP-IDF. So they mention the release cycle. So you
Mm-hmm.
can see version 5.5. It has been released 21st
It's very
July.
new.
It's pretty new, yes. Yeah, even the environment I have it has picked it up, but I'm not sure. So it says there is a service period, so it says it is recommended for new designs. And then there is a maintenance period, which basically they fix some of the security issues. But anyhow, when you design a product, you need to make sure it is remotely updatable, either by the user or automatically. Which then probably if your product, for example, was developed 2 years ago, and it supports remote firmware update, you can compile a program with the latest SDK and update the flash memory with them.
Mm-hmm.
It's a quite important feature of these Wi-Fi BLE devices. You need to make sure that device is updatable. The installation of ESP-IDF is pretty easy. They even
So this
provide
is, but
tooling.
this is where the
Yeah,
important thing is starting, correct?
exactly. ESP-IDF is a bit complicated. It takes a while to understand how it works, but it's quite useful. It uses a mixture of Python command line and a Pythonic build system and CMake. CMake is another build system that is used. It is a bit common in embedded software and in software that uses C, C++. I would say CMake is the most common build system. And then there are other ones. CMake is well, mistakenly we could say it is a modern version of Make, but Make is actually the build system. CMake is a build system generator. CMake can output Ninja and Make files that can be used to build the final artifact. These are about CMake itself.
I would
So
like to point out, so because not everyone knows what makes means and C makes mean or how
yeah,
they are used. So basically, uh, it's the way how we, for example, build software on Linux. We can download source code and we use this CMake to actually create the application which can run.
yes,
Okay.
exactly. Yeah. So there are different ways to install the the ESP-IDF. So usually you have to go through the manual installation. There is a Windows installer and Linux and Mac installer. But if you don't want to install these SDK manually yourself, you can also use a VS Code extension or Eclipse plugin.
Oh, I
But
didn't know.
yes, yeah, these two exist, but well, as it is recommended as a beginner, at least if you want to start with building and using ESP-IDF. But the manual installation is more, it gives you better experience of how stuff works because at the end, in your project, you might face some challenges that you need to dig into the IDF, into the SDK itself and understand how it works, and then try to change the configuration, which the manual installation is a bit easier. I guess this VS Code extension is pretty new, so probably majority of the users don't use VS Code extension now. Maybe it has improved a lot, but in this tutorial we go through the manual installation, which is
Hmm.
pretty straightforward. Uh, but it was the common way of doing that. Maybe it has been changed a lot. But if you want to go through the Linux or Windows installer, because I have a Ubuntu machine, I go through the Linux installation approach. So it gives you this instruction steps. As you can see, you have to install some packages. You might hit some errors, and then depending on if you are on Mac and one processor, you might hit some other errors as well. So you could see that the manual installation, it has some dependencies that you need to install at the beginning before you can go and install the IDF. So this is the
Hmm.
command, install the IDF itself, and then specifically installing the targets that you have. You can say it is quite a repetitive task, but once you do it, that's enough one time. The other problem with this approach is it messes with your machine because it installs everything globally and also it messes your home directory. Uh, and if you want to switch between different versions of the IDE, you might also face some challenges because during your product development, you want to switch between different versions. Some versions they have a different bug, and then the other version has a different bug. So what usually happens is that, I mean, this is what we do, what I've done in my almost everywhere I've worked as well. We use VS Code Dev Containers feature, which basically you create a shared environment with a specific set of prerequisites with the same packages. So for example, if you work in a team of 5 people, you you want to develop inside a container, and the reason is that the container is the same disregarding you have a Windows machine, you have a Linux machine, or you have a Mac machine, because you can see each of these machines, they have a different installation, and you have to install different packages that might be on different versions. This affects the final product if the versions don't match each other. So that's the reason we usually use VS Code dev containers. I have already provided or prepared a starter VS Code ESP32 environment for you, which is basically a repository with the basics of ESP32 SDK, and it uses VS Code dev container. For those who don't know VS Code dev container, let me quickly uh, VS Code has already provided a good tutorial of how it works. So instead of running everything locally, you create a container and mount the file system into the container. And the container is in your control because you can define what needs to be installed, which version, and how it should be installed. And
And the
this
container
basically,
is running on your machine?
the container runs on your machine. Yes, yeah, it is. It is a Docker container. Recently, VS Code allowed using Podman as well, which is a different virtualization or containerization solution. But Docker is quite mature and useful.
But this is interesting. So it's like virtual machine.
It is a lightweight virtual machine because the difference between containers and virtual machines is, in case you didn't know, a virtual machine tries to it abstracts the processor, so the whole operating system kernel in a virtual machine is integrated in the virtual machine itself. So you are basically simulating the processor itself. That's a bit more resource hungry. So you need to have a powerful CPU. But containers, they use the same OS functionality. For example, Docker containers on Linux, they use the Linux kernel that is already on your Linux installation. So it is like a process running on your machine, and it uses the same kernel, the same device drivers, and the same processor. So it is a bit more lightweight.
But then
We could
how can you move container between different operating systems?
so the containers are built at runtime. So you define a recipe for the container that I want the container to include this. So let me show you how it works. There is
I'm
a
sorry, asking this question is we go
yes,
off the track, but
that's a new trend. I would say not all of the embedded software engineers are familiar with Docker containers, but it is a important aspect in professional embedded software engineering because you want to let's understand what is the purpose of a container. We want to share the same development environment between the team members. If you have suppose that you have a team of 7 people and you want to make sure the version of CMake that one engineer uses doesn't affect your product, because one engineer might build something, it works on their machine, and then it pushes the code to your repository, and then it breaks something on someone else's machine because they use a different version of CMake. This is one example. I'm not talking about the libraries or the ESP-IDF versions. So
yeah.
you basically enforces the same version across all team members.
So basically also you can kind of uh, run specific versions of software, like even the application software for
Exactly.
specific product, which was maybe released 3 years ago. And if you would like to go
Exactly.
back, then you need to open this specific container to actually work on the software.
Exactly. Yes. And Docker containers are pretty easy to build. So there is a file called Docker file that it defines what the container should have. And it is pretty straightforward. You can see Docker file syntax is like running shell commands, but you define it as layers. So you say that I want a container that is based from a fresh Ubuntu 24 installation. Even if you are on Windows, you have access to a Ubuntu 24, specifically this version. You can see we have versionized it. And then the user, the root access, the packages that you need, it's like the recipe. And these are command line arguments. You can see apt get. So it is basically telling Ubuntu to update. When building the container, it follows all of these steps line by line by line. And finally, when it reaches the final step, you have a container from a Docker image.
Hmm.
And you have a Docker image, and then the container is built from an image. Uh, but VS Code handles all of it for us. We don't need to even write a single line of code.
Hmm.
You follow this. I
So
will
if
show you.
someone would like to learn more, then maybe study containers.
Yes, yeah, they can quick. There is a good tutorial of VS Code, dev containers, how it works, what are the advantages, and how it can improve your efficiency. So you can see we are specifically installing a specific CMake version. This is the latest CMake version, by the way, but it is the same across all of the development environment. And you want to also, when you use, for example, workflows or automation, you want to make sure the application is developed with the same version that it is going to run what by the test if you want to run it in a continuous integration pipeline. And when you want to release the final artifact, which is the final firmware binary, you want to make sure it is built with the same versions. Because if it is with a different version, it is going to break the tests. And later on, you might face new bugs that you didn't know in
Hmm.
advance. This is quite important for any serious product.
Hmm.
Uh, so we are also installing Python. And the last step, after we have installed the prerequisites, we install ESP-IDF.
Hmm.
And then I have also specified that we want Series 2 and Series 3. These are the most common ESP32 series that we are supporting here.
Hmm. So
The rest
if I,
of it,
I'm sorry for
yeah.
interrupting. So basically, because we don't have much time, it's like what? So what I'm thinking about is, so basically, everyone who is watching this video they don't really need to install the IDE. That's the point. They can
Yes.
download this, what you prepare, this container, and then what they need to do then.
Yes. Okay, let's do it. So I let's see what I close Arduino. So I press Control C here. I go to the or direct to any directory. I have already cloned the repository. So if I go to ESP32, so you can see I've just cloned the repository. Well, git clone is the way to go. I've already cloned it and then use open VS Code inside it. So I press code dot. It opens VS Code on the repository itself.
And if someone is using Windows machine, they basically
It is the same thing.
open they or set the visual code to this directory where is the container.
Exactly. They can open it through here as well. So if they can
Ah,
open
mhm,
here, they go to VS Code starter and the repository that they have gone, press open. It opens the repository.
mhm.
And yeah, it is the same thing as I have pushed it to GitHub.
So
Uh,
they need to install
also,
Visual Studio Code, but this software is free.
sorry, I didn't get that.
They need to install the VS
Oh,
Code.
yes, yes. They need to install Visual Studio Code. So I assume that they already have installed it, but it is easy to install it. You can go to VS Code and download it from depending on the operating system you have. You have the Debian version or RPM version. It has detected I'm on a Linux machine already, so it gave me these options. But on a Windows machine, you are given the Windows installer
Mhm.
that you can use.
Okay.
So once you are inside the VS Code, you need to also install this extension. It is called dev containers.
Mhm.
By default, it is not shipped with VS Code, but once you install it, it lets you to use the functionality of dev container. This is an extension.
Mhm.
And the definition of so there is a file that tells VS Code that there is a dev container configured for this repository. This is the file called devcontainer.json in a specific directory called .devcontainer, which basically tells build the container from this Docker file, and it tells you I want VS Code to install the following extensions inside it. The rest of it, I don't go into that, but basically it lets you use Git commands. So if it brings the SSH keys into that, or if you want to program the device through USB, it also brings the stuff into the Docker environment. But you don't need to deal with that. It's already there in the repository itself. And just to tell you that you don't need to go to use the dev container if you want to run one example. But I wanted to tell you how the industry is using VS Code dev container for embedded software
Mhm.
development. This I know this is a bit complicated at the beginning, but it is something that if you want to work as a professional software engineer, you need to know how Docker containers works. So once you are inside VS Code and have the extension ready, you can go to the command palette. So if it was run, if the view command palette here, I usually press Ctrl Shift P, and then you can type rebuild or reopen in container. Uh, Maybe you can just type container. There are different functions, but the dev containers extension tells you what it has to do.
Mhm.
So you can specify rebuild and reopen in container, which basically it rebuilds the Docker image and it installs the items that we specified in the Docker file.
But this is interesting because I know sometimes I don't like to install these IDEs because you have to
Yes,
install Python, you have to install this, you have to install that,
exactly.
and
Yes.
and then your computer is mess.
Yes, yeah, but some applications they require a specific version of Python. For example, if you have Ubuntu 20, for example, which is 4 years old, and you want to use the latest Python version that is not shipped by default in your Ubuntu version, either you have to change the source that it downloads it from, or you can use a development container that has the latest version in it. So you don't need to change the configuration on your side. There are different methods to do that. Uh, let me just hide this. Okay, so the repository is there. We are already in the container. So I close this terminal. I open a new terminal. I've already mentioned in the README file how this repository works, different links to VS Code, Docker, what are different versions, how to use it. So I've even specified you can clone the repository
Mm-hmm.
inside the repository. By the way, most of the README is generated by the coding agent I use. I use GitHub Copilot myself, so it is pretty good, and you can just tell it, I want a tutorial on this, and just generate it for you. I didn't need really change anything. It has detected all of the files in the repository and it has provided a good tutorial. So once you're inside the container, I have already specified that the ESP-IDF is installed at in the home under the home directory, but I also put it in a environment variable, IDF path. So you can see it has been installed here. So now we have a container, we have a working environment with all of the prerequisites and ESP-IDF installed. So
So basically,
let's run
even if
examples.
someone is running Windows, they will see exactly same stuff.
Exactly the same thing. That's the beauty of Docker containers. You have the same experience disregarding your host operating system. And the same packages. Some packages, for example, are not your package manager for Windows. It's not the same as you have it in Linux.
Mm-hmm.
I mean, WSL on Windows is quite useful, but still you want to share the same environment.
Even this path will be same, like /home/Ubuntu.
The path would be the same.
Okay,
The whole thing, you are sharing
I
a
understand.
single.
I understand. I just wanted to confirm.
Yes, yes, yeah, yeah, oh, yeah. All excited to tell you different features. Yeah. So once you're here, I can now open ESP-IDF itself. Or I want to open the repository. It has, so the same thing we did for Arduino, it provided lots of examples. ESP-IDF on the repository, it provides lots of examples as well. For Bluetooth, you could see that for Bluetooth, we didn't have any Arduino example because Bluetooth is a bit advanced application, even from the Arduino perspective. But it has the examples are pretty useful because it tells you how to use the API of ESP-IDF in your application. So let's just run the LED example we
Mm-hmm.
did here. Uh, if you go to getting started examples, there is a Blink example here. And it has ESP-IDF, as I said at the beginning, it is a bit more advanced, but the reason it is advanced is it gives you the flexibility. So you can configure everything. It has already provided different configs for different processors. And then if you read more about ESP-IDF, you can basically have the same project, but build it for different SoCs, for different modules. So the same application, the same firmware, but it runs on different product families of Espressif. That's a nice feature. So let's open this example in our dev container and follow the steps
Okay.
mentioned in the README file. So I go to the container we have. By the way, the root repository, it is a template project, but as I mentioned, ESP-IDF is installed at this location. So we
Mm-hmm.
can just go into that specific location with, because it is the source repository. If I type ls, you can see it is the same repository. It is
Mm-hmm.
cloned here. So we go to the examples directory, see the examples, and then get started, and then blink. So here, if we want to have the files on the left
Mm-hmm.
side, we
That's
can
what I was
run.
thinking about.
Yes. So if you want to have the files, just press code dot, and it opens a new instance in the same container.
Mm-hmm.
So you can close the previous one.
Mm-hmm.
And now you're in the container.
Oh, okay.
Okay, So the first step when to use ESP-IDF is to first bring the environment variables or the tools it provides into your shell environment because it is a command line tool utility. So the way ESP-IDF tells you is that once you know the exact location of IDF installation, so it is echo IDF path. So it is installed here. You can source a folder, a file, a shell script called export.sh. Uh, by using the source command in shell, we are basically bringing in we are enabling IDF commands inside our shell environment. So you can see it checks the Python version we have. It says we have this Python, and then it activates the ESP IDE version. So we have got 5.4, but if you want to change the ESP IDE version, you can just change the Docker file. And I told you where we installed that, so you can just change the version and you have a new version. So now we got here, we can follow the steps provided by the example.
So
So
with the command, you kind of set up uh, our environment where we are going to run the
exactly,
example.
exactly.
Okay.
So here it says that because this example is designed for different processors, you need to run the
Mm-hmm.
target. You need to specify the target you have.
Mm-hmm.
So here we specify target, but I don't pass any argument. I just want to see available options. So
Mm-hmm.
it prints the available options here. For our case, it is ESP32
Mm-hmm.
S3. So I run it again and I pass ESP32 S3. So what it does is that it is a way that ESP-IDF configures your project. So it generates the build files required for that.
So
And
everything what we
then
are going to do now is going to be related to the S3 microcontroller.
exactly the same thing, yes. So it tells you that to run this example, you need this LED, addressable LED on this board, and then it specifies the dev kit, for example. And so once we have specified the target, we can run idf.py menu config.
Mm-hmm.
This menu config is a powerful command which brings a GUI inside shell. It's quite
I know
useful.
this from building Linux for.
Exactly. It is the same mechanism. It is using kconfig, which is a utility developed for Linux kernel utility, to configure Linux kernel. But that tool is now a separate project than separate from the Linux kernel. It has been used extensively in ESP-IDF. So you can see you can specify lots of configuration. Well, this specific example we have, it's called example configuration. You can define your own configuration by creating a kconfig.project build file, and then you need to write the syntax you want. So you can configure your examples as well. But let me let me check what configuration it has. So it tells this LED blink type. So we are going to use LED stripe
Mm-hmm.
because it is the one that we have.
Mm-hmm.
Let me just hide this for now. Because I press escape, it brings it again, but I will hide it.
Oh, and then you can select what GPIO pin it is
Yes, yeah,
connected.
you can change the GPIO, but the default number is good for us. You can also change the blink period, so you can set it to I set it to 1500.
Mm-hmm.
So
Can you change because there is only one, then you don't need to
yeah,
configure like number of
because
LEDs or
it's the
something.
same port exactly. There is the backend peripheral as well. For us, it is called RMT. I always forget the what RMT is. Let me just Google it. ESP RMT. It is remote control transceiver. So it is basically the same interface that is used to control the addressable or RGB we are using.
Mm-hmm,
So
mm-hmm,
our backend, by backend, it means that we are using this protocol. You can have also SPI controllable LEDs, but on this board, it is not SPI
mm-hmm,
LED. It's
mm-hmm.
just an RMT LED. I keep it as it is. So once you press escape in the last menu, it asks you, do you want to save it? Here you press yes. press Y and it saves it for you. We
It
hide
keeps
this
opening.
again. And once it is there, you can specify IDF type. Well, we can follow the same command here. So it tells you the same information I gave you here.
Mm-hmm.
And then you can specify IDF.py dash P port. It is the USB port that you want to use for programming the device, and then flash and monitor itself. So flash means it flashes,
Program.
flash is like compiling the program and then loads it onto your flash memory. And then monitor, you can chain multiple commands in IDFI. Monitor is basically after the flashing is finished, it opens the serial port,
So we can
which you
see
can
some
then
kind of
see the
debug.
output. Yes. So I will specify dash P. So I know my device is connected to a dash dev TTY8CM0 because we use Arduino, we know it is there. And then I specify flash and then monitor. So it now is executing the compilation process. That takes maybe a minute or two. You can see it is building 1,000 files. So because our example is just one Blink example main.c file. And we can go through that this example as
Mm-hmm.
well.
But we are building 1,000 because it building all the libraries and
Yeah,
everything.
it is building the SDK as well, and
Mm-hmm.
it when every time you change the configuration of the library, it rebuilds everything.
Mm-hmm.
So usually you have to build it one time, and then it is smart enough. It doesn't need to rebuild it for you.
Mm-hmm.
So uh, you see that the application, so this is quite important and it's different from Arduino. The main function is called app main, and basically this represents the same structure as Arduino. So you do all of your first time after boot stuff here,
Mm-hmm.
and then you implement the while. It is the loop function.
Mm-hmm.
As you can see, we specify configure LED. Well, I don't go into the details of that, but basically it checks the config flags we already have given to it, and then it sets the specific port of the LED, and then here it goes through a while. It prints the status of the LED, and then it blinks the LED. It changes the state because it is turning on and off, and then it does a delay. For the delay, so we specified, if you remember, in the config period, we specified
1.5
the
second.
LED should be, yes. Oh, it is already programming it as well. So you
Mm-hmm.
can see now on the LED is blinking.
Ah, it's working.
Yeah, it is working. Yeah, and it is printing the same print line we specified. It is the ESP log
Mm-hmm.
information.
So this is
It
when
is
the
telling,
monitor was actually
yes,
from flashing. Once it stopped flashing, then it automatically switched on the
exactly.
monitor.
Yes, I can come out of monitor here. So by pressing Control and the right bracket, it comes out of the monitor.
Uh-huh.
And then you can specify IDF type pi, p, dash p, dev, ttyacm, and just monitor is
Mm-hmm.
enough. And you can again open the serial port. So every time you run the monitor without any argument, it resets the microcontroller, and then that's the reason you could see the output log from the reset line
Mm-hmm.
from the beginning. So it is quite useful to take a look at that. So here, the first thing it prints is the version of the ROM that is already programmed, and it cannot be changed on the ESP. And then it is the build of the ROM, and then it checks the clock, some basic functionality, and then this is the second stage bootloader, and then it prints lots of information about the frequency of the firmware, the connected hardware, these stuff. And then after the first boot lines are gone, then it calls the app main.
Mm-hmm.
Then the whole application starts.
Mm-hmm.
There is a fun project on ESP32 is that you can compile Linux kernel and run a Linux shell on ESP32. It is not powerful, but it is a fun project, and it is already on GitHub. But I recommend people to take a look at that. It uses ESP-IDF. It compiles the whole Linux kernel. It has even the Wi-Fi stack on it, which shows how powerful this SoC is.
Okay, now if you would like to change something, we can change it directly in this code, or we can,
Yes,
for
we can
example,
change
the
it.
frequency, or we can also
Yes,
go through the
frequency.
setup again and change the.
Depending on what you want to change. So if you want, so here the frequency, for example, we change it from a configuration, but I don't need to change to choose a configuration here.
You can just write
I
there
can, for
500.
example, yeah, change it, for example, to 1000 milliseconds.
500 because then it will be more
Oh,
visible.
500, yeah, it blinks faster. So one thing it is important is the delay function here. It is a vtask delay. It is a free RTOS function, which basically delays a task. App main, it is a thread. It is the first, it is one of the main threads. And when the application is booting on ESP32, depending on if you have Wi-Fi and BLE, it runs multiple threads. But this is the main thread that runs. And then if you want to tell to delay, you have to tell it by the number of ticks of the processor. By default, free RTOS ticks, the frequency is 1000. So every millisecond, you will get a tick interrupt in free RTOS. And when you say 500, 500 divided by 1000, that's the ratio it chooses to do a tick. But let's do the same thing again. App flash monitor to increase the frequency.
Works now. Okay, are you going to do also the Wi-Fi? We have to do it very quickly.
Let's do the Wi-Fi example as well.
What do you say?
Uh,
Like going to take 1 hour, or what did you say at the beginning?
oh yeah, yeah. I guess we did a lot. Yeah, at the beginning I thought we can go quickly through all of them, but you see it is lots of details,
This
and
is
yes,
super
it's complicated.
useful for me. It's
Yeah.
super useful.
I hope it is useful for the audience as well, which I am pretty sure because it is something that I remember at the beginning I had some issues of how to use ESP-IDF at the beginning. And yeah, now I can share this experience with people. So let's open the Wi-Fi example. So we go
Hmm.
to the examples directory again, and then let's type ls. So the example we want to run, it is under the protocols because
Hmm.
HTTP web server is a protocol. So we go to protocols, and then there is a example called HTTP server.
Hmm.
So we go into that directory. Let me see. So there are two versions, HTTP server and HTTP
Hmm.
server. HTTPS is using encryption. It's a bit advanced. We don't go through that. So we just use HTTP server. And then there is a simple one, well, the simplest.
Hmm.
So we go to simple and let's see if it is, yes, this is the correct one. So I open the VS Code directory
Hmm.
again here and I close the previous one. Let's do it like this. Meanwhile, it is loading. Meanwhile, I go to the same thing from here if it is easier to read. Protocols. HTTP server, simple. So basically, we have to do the same thing as we did uh, to configure it, and then it specifies some configuration that you can do.
Hmm.
So we let me just hide this. So we specify IDF that we need to source the IDF environment variables. So we specify the target again as set target because it creates a new build directory in every project you go. So you need to specify it. ESP32 S3. So it has configured it. Before we just run the example, uh, I want to make sure we have the right configuration. We go IDF.py menu config, and then there are two configurations
Mm-hmm.
here. Connection configuration, which specifies how the Wi-Fi should work. Because I mean, any HTTP server, you need to first solve the Wi-Fi problem, and then you can access the web server. So we do the same thing. We specify the Wi-Fi credentials here. There's a Wi-Fi SSID, call it Amir test. This is what I've created already.
I guess
And then,
theoretically it is also inside of the code, but it's better to configure it from here.
yes, yeah. The same config definition is used inside the code. So you can also override it in the code itself. But this is providing a nicer user
Mm-hmm.
experience. Okay, Wi-Fi pass. Oh. You can specify the retry as well. You can also specify if it uses IPv6. I disable it for now because my router doesn't support IPv6. And I guess that's it. I press escape. And there is another example. So you can also have basic authentication, which basically if you want to open a web page, you specify a username and password. We don't want it for this simple
Mm-hmm.
example. We just save it and hide it
So this
again.
always open when you press escape.
Yeah, when I press escape, it brings it up. It is Zoom behavior. And that should be, I guess, so we try to run the web server first, and then if we want, we can also change it to control the LED. So idf.py, specify the port, which is a slash dev ttyacm0 and flash monitor.
Can you use also like arrows up or down here to easily repeat the commands which you
Oh yes,
normally
yeah,
use?
you can. Yeah, it is a Linux shell. Yeah,
Mm-hmm.
you can use. Yeah. So because we changed the config, it is rebuilding everything, and you see it creates a build directory here.
Mm-hmm.
So this is the output of it. This is a temporary file, so you don't need to touch the files here. Sometimes for debugging, you might want to go to see why CMake, for example, failed to do something, but usually you don't need to see that. Meanwhile it is building, let's go through the app main. So first it tries to initialize the flash. The reason it needs to do that is the Wi-Fi stack. It requires the Wi-Fi password and SSID to be kept on the flash itself. So you need to initialize a file system. Uh, and then you initialize a net interface. This is the how ESP-IDF works. We can further take a look at the SDK. Then you need to create the event loop. And then the example connect is basically connecting to the Wi-Fi access point that we have already provided the details. We can go into the function later. And because this example gave you the option to connect to Wi-Fi or Ethernet,
Mm-hmm.
our module doesn't have Ethernet connectivity because it requires an Ethernet chip. But ESP32 is able to connect to to Ethernet I would say transceivers via SPI. So it works with a physical connection as
Mm-hmm.
well over Ethernet. But yeah, for now, we don't do that. We don't have it. And then it starts a web server, and then it keeps the main application alive for the web server to work because web server runs on its own thread. So yeah, then a start web server is the function that creates the web server. You define the same thing we did with Arduino when you have a server object and then you define the endpoints. So hello, for example, if we go to hello, it says that it's a different API, but it is nearly the
So
same
it's like slash
functionality.
hello.
Yes, a slash hello, it calls the hello get handler.
Mm-hmm.
And at the end, it is a context that you can pass to this function as well. So if you go to hello get handler, this is the HTTP request you receive, and then you can probably process the information received by in the request. And at the end, well, it is trying to find it tries to break the HTTP request data that it receives, like the client, the URL, these are stuff.
This is
And
the
at the
simple
end,
example, yeah.
This is a simple example. Yeah, this is the simplest one. And then it prints the output. ESP-IDF is a bit, I would say, advanced, so we need to spend some time. But all of with these function calls, especially the memory management ones, here, for example, it is freeing a buffer. If you forget to free that, your product fails at some point. So you need to make sure this memory corruption doesn't happen. So now it has flashed it and it has programmed it. You can see it has printed the IP address. So I can copy the IP address and I open it in the browser itself. So when you strike any, it has answered hello world. So depending on HTTP verb that you want to listen to, this any basically says either it is a get, it is a post,
These are different examples.
Yeah, different examples, yes. So if you go to any handler, so this is a simpler one than the hello one. This contradiction. So it just whatever it is received, it just prints it. Because we didn't post anything as well, we just printed the context that was provided. So which basically is hello world here.
This was really good. I learned a lot of new things, especially I learned about the setup in Arduino. I had no idea I can do all the kind of setup, because I remember there were some times when I actually had problems flashing the ESP32 through Arduino environment, and maybe it was something inside of these settings which I should change, and then it would work. So this was very
Yes, the
important.
settings are important because if you don't choose the right flash size or CPU frequency, the firmware doesn't run and it doesn't give you a clue. I mean, at the beginning, I tried to change some stuff, and yeah, it didn't work. So yeah, the Arduino debugging capabilities is a bit limited, but it's a good starting point.
And then second time, these containers. This is really interesting. I didn't know this exists, and it's super useful because if I would like to try the this IDF now, then I know I don't have to install everything. I just can use it like you did. I can download your repository or clone your repository
Exactly.
and just use it
Yes.
exactly as you show. And I don't need to install stuff on my computer.
Yes, yeah, you can clone the repository, change it to how you wish. You can change the dependencies. I guess as you invest more time in how to use it, or your audience, if as long as they spend time learning how it works, they get familiar with it, and it's not that complicated. The SDK is very powerful. It provides lots of functionalities, and it is probably one of the most modern SDKs for embedded systems compared to the other chips, I would say. I guess you will have fun time using ESP32 and ESP-IDF SDK.
So if anyone would like to see more advanced examples using the Espressif IDF, then leave comments and we can maybe make more examples, correct?
Definitely, yes. You can go into depth of different topics. Yeah.
Thank you so much, Amir, for this.
Thank you so much. Thank you. I hope you have a nice time.
That's all for this video. I hope it was helpful. If you would like to learn more about electronics and board design, check out our online courses. You will find everything important there, from basic board design up to advanced board design and high-speed PCB layout. We have courses in Altium, Cadence, KiCad, and also courses covering many different topics, for example, FPGA, EMC measurements, and so on. Visit our website at fedevel.com. That's all for this video. Thank you very much for watching, and don't forget to leave your comments. See you in the next video. Bye.